it could have been somebody's bladder in IAD.
Okay. So there it is. And let me do this. Hey everybody, welcome back to HPC Tech Shorts, the engineering water cooler here in AWS. I've gathered a couple of people here today. Angel from my teammate in Philly. Hey, Angel.
Hey.
And Ian Colle, the GM for HPC, the big boss. Hey, dude.
Hey, Boof.
So you guys were at reInvent last week. There was a crap load of stuff that went on at reInvent last week, and that's a metric crap load. There was an awful lot of stuff that happened at reInvent last week that was, in the end, HPC related and good for our HPC customers. So I wanted to get together to talk about some of that and to just do a recap. Where do we want to start? I kind of want to say there were a couple of things that were sort of tangentially that were just kind of geek chic. I thought it's pretty cool that we launched an Apple M1 instance.
Yeah, it's definitely like Apple ecosystem is really driving, ARM-based computing, and for right now, most of that is being driven to mobile applications, right? But I think that with the Fugaku ARM supercomputer out there in the world still maintaining its lead, everybody in the HPC space is incredibly interested in ARM-based architectures.
Yeah.
So
it's something like 200. I think somebody mentioned to me the other day, 200. There are 25 billion ARM processors in the world, or something insane like that. It was an absolute bonkers number. ARM chips that are in the world, and cell phones and embedded devices and Raspberry Pis that run my house. There's probably 12 of those.
And as we get developers, developing on their local laptops with ARM, then they're going to need to scale that to test someplace. And the M1s are pretty cool. And I think that right now, maybe there's not a direct use case for it in HPC, but looking towards the future, let's see what folks do with these instances. I think
now, of course, there's some other ARM instances that got announced last week.
We'll talk about those later.
We'll talk about that at the end. We're going to make everybody hold back and just
right.
Keep everybody in suspense for a bit.
Ian, tone down the temperature. Let's talk about file systems.
Yeah. Let's exactly.
Come on, file systems are exciting too, people.
Oh.
Excellent. So, spoken like a Lustre dude. Okay, so Mr. File System, FSX for ZFS, is that geek and weird? What do you think?
It's geek and weird and tremendous. I mean, I think all those use cases that maybe said, I'm not sure if I really need, say, the scale and the magnitude of a Lustre file system, but I'm really want something a little more performant than some of the NFS offerings we've seen to date. Something like OpenZFS is exactly what these customers need. And so whether it's the speed or the throughput, I think our customers should take it for a spin and see the performance of their apps, because the initial feedback we're getting from our customers is anywhere from joy to delight to, oh my gosh, I didn't even know I wanted this, but now I'm so glad it's here.
That's what most people say after they use ZFS for the first time. I didn't know I needed this, but now I have to have it.
Now, aren't you supposed to say ZFS?
Yeah, well, we could debate that all day, but potato. Now the FSX for ZFS, they built all that stuff on Graviton, right?
They did, as well as the next generation of Lustre offering. And I want to kind of transition into that. Is that just shows you how the innovations that we're making at the silicon level tend to ripple out throughout our service offerings. And you can see that the investments that we made in that Graviton ARM ecosystem allow us to then develop these highly performant, more cost-efficient offerings for our customers. And that's what's so exciting, especially when you apply it to what we've been able to do with this next generation of Amazon FSX for Lustre. I mean, talk about just a game changer. I mean, not to transition away from ZFS too much, but that's where I really see that you look at I'll call it the offering one, the initial FSX for Lustre, and now this offering two based upon the Graviton instances. And when you're getting 5 times the throughput, I mean,
Yep.
that's not bad.
And that yeah. So I mean, I got some notes here that I got from the Lustre PM this morning, and he's like, the new file systems provide up to 5 times higher throughput per terabyte. That's a gigabyte per second per terabyte. That's how they scale those things. What else was it? Oh, that's right. And he was actually pointing out that now that we're actually producing instances like the DL1 and the P4D that have got 400 gigabits per second instant, network adapters on them, the Lustre file systems now, so the clients are actually now capable of draining that extreme bandwidth off Lustre. So there's that, and then he said third, reduces, what is it, the next gen of Lustre file systems, reducing your cost of throughput by up to 60%.
I mean, I don't know how do you say no to that, right? Cut your costs by 60%, improve your throughput by 5x, and as you noted, Boof, whenever we're looking at HPC workloads, it's all about kind of finding the different bottlenecks and optimizing around wherever the next bottleneck is. As we improve the memory bandwidth, as we improve the network throughput of these, I'll just say monster distributed machine learning instances of the DL1 and the P4D, you got to find where's the next bottleneck. Well, for some of our customers, that next bottleneck was the file system IO and the throughput. And so that's why we're going to continue to drive innovation throughout the architectures, because we're going to continue to chase down those bottlenecks to improve the performance for our customers.
And so the other thing that caught my eye with FSX for Lustre was the other stuff. It's maybe not the performance related things, but it's the convenience related things. So it's like asynchronously linking and unlinking S3 buckets to be the back end of the Lustre, so that it's the Lustre is synchronizing with those S3 buckets. You could come in and cook an FSX for Lustre off like fill it up with data from an S3 bucket that might be a public data set. And this would be in your bag, Angel, in the genomics world. Soak up like 1,000 genomes and shove it into an FSX for Lustre file system, and then work on it for 2 hours doing some kind of enormous analysis, and then push it out into a different S3 bucket when you're finished. Mm-hmm. You're essentially using FSX as a giant sort of, burst buffer.
Yeah, and FSX used to have that as well, but you had to be deliberate about pushing it back once you were done. And this new feature is actually more transparent to the user. It allows you to do it. And more importantly, because it is transparent and it's checking on your behalf, now it opens up the possibility. We'll have to see and test it with our customers, but to have the same sort of read-only cache from S3 being dropped into multiple AZs and multiple FSX or Lustres, so that your algorithm can scale not just within a single placement group, but maybe have a star pattern. You're looking at different parts of this so that you come across much more, this sort of newish architecture, because you get better throughput and performance with less instances. You might have the same economics, and again, we have to test this, but the same economics to spread out your load across the whole region, or maybe even multiple regions one day. But at least for today, there were a lot of workloads where it made the price performance aspect of trying to get a result fast enough that you were bound by single AZ. And I think we're starting to see the possibility with some of these usability features coupled with the performance features to look at real HPC multi-AZ architectures that are going to be scale and be performant and not cost an arm and a leg. So I'm pretty excited about usability features like this and what it opens up from an architectural pattern.
Well, and also, I think that shows the strength of the AWS systems, right? Because we're interoperating here at a level where, let's say if I'm my standard on-prem Lustre file system user, I don't get this seamless integration with any sort of an object store. I don't get the ability to do these kind of operations that right now we're helping some of our customers make key portions of their workflows. So right now you can take standard tools that you use to operate and manipulate your S3 object store for other portions of your workflow and have that dynamically then be reflected in that POSIX compliant Lustre file system that then you need for the next step in your workflow. And so that's where I think that the key is about AWS is once you've got this data in these systems and then being able to manipulate it and utilize it with the access patterns that you need. Do you need object access to it? Do you need file-based access to it? And then shutting it down when you're not using it, and only paying for the access and the features that you need when you need them for that portion of your workflow.
And as much as you must love your WAM cloud days, and Lustre's hard to build. It's complicated to build. How many people would have jumped for joy if you'd said to them, you can have a button to turn your Lustre on, and when you're done with Lustre, you turn it off, and your data's safely stored in an object store where it's easily backed up, and blah, 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 blah. It's cheap, it's low cost, it's safe for the long term in an object store. And if we need it fast again, we'll just hit the Lustre button again. How happy would people have been with that?
I think you see that by the number of people that are jumping onto Amazon FSx for Lustre. I mean, it's a little cliche to call it like an easy button, but seriously, when we take that heavy lifting away and we do that management for the user, both the scaling, the dynamic allocation to S3, the hydration, and really that takes that away from the customers, and we're able to provide that functionality for them. And that's really the value add of FSx for Lustre.
I'm pretty sure that all three of us have been in plenty of data centers late at night and at the mercy of Lustre file systems failing because battery back write caches in controllers. SCSI died and stuff.
Oh my gosh, you're making me twitch as I remember exactly that. We didn't have battery backed cache.
Oh yeah. Tell me about the battery back cache anyway. Now let's I want to talk about these things because the IM4GN and the IS4GN instances popped out. They're driven on Graviton processors, Graviton 2s, but they've got SSDs made by AWS now.
And that's one of the key things that I don't think we talk enough about is as we went out to the market and talked to our customers, what they told us a lot is, you know what, for some of my workloads, I really need a more consistent tail latency. Really, it doesn't do me any good if I've got like 95 or even 99% of my reads and writes at a certain point, and then all of a sudden I've got this one dog that slows the whole thing down, and I don't know when it's going to happen, and it really hangs up my workflows. Can you do something about improving the tail latency? And that's why really when we went and looked at what would it take to take the technical innovation that we've learned from our network cards and from our CPUs and say, why don't we apply this to an SSD? And so when we went to build out this SSD, one of the key metrics we said is we've got to improve our tail latency. We've got to really narrow that window of performance so we can provide more predictable performance to our customers for their workflows, because that's what's so essential. And so with these SSDs, we think you'll see a marked improvement in that overall latency. And so that's where I think the true strength of these new instances is that it is a marrying of both the Graviton 2 CPU, but now with this new Annapurna Labs developed SSD.
Yeah,
definitely that base hardware Nitro ecosystem. It has been proven out in a network. It's been proven out with, being able to bisect storage versus instance network. Our management plane is now there, freeing up all the instances of all the resources of the instance. And then, a couple of years ago, we built our high-speed networking EFA on it and started rolling it out to the fleet. So I think this is a pretty good segue to talk about, these things do have the SSD performance, and then there are other instances that got introduced with EFA as well.
Yeah, well, let me just I just got to get this up because I got to show everybody this. This is yet again we're seeing something that is just, I think, just screwy. I wrote a blog post less than 1 month ago. It was the day after my birthday. Hint, hint. It was the day after my birthday that I wrote a blog post about EFA, about the vast number of instances that supported EFA. And here we are less than a month later, and the number of instances that support EFA is like increasing.
Honestly,
yeah.
which is great. This is great for our customers. They're finding the value when we had it, and it's typical AWS where we release something, folks find it valuable. Sometimes it takes a longer time frame for that value to be realized. through enough of our customer base to bring it to other customer bases, right? And telling those stories of success helps us drive the roadmap, and here we are today. And I'm just really excited to see what the future.
So there's storage enhanced instances in there. There's Graviton ones, there's ARM ones, there's AMD ones, there's Intel ones. We've got multiple generations of GPUs in there, and then we've got Inferentia. We've got we've got the DL1s. The
video transcribing, the VT1s, right?
Yeah. I actually had to look up what that was. The video transcoding instance. Right. So we've kind of gone
not whole training.
Yeah, we've gone completely crazy.
Well, it's hard to believe when you look back at where we were with just the C5N,
right?
And thinking about, wow, where could this go? And we talked a lot about the promise of it and where we thought it was headed. But it, to be honest, I think it was a lot slower in realizing that dream than many of us are happy about. But now that we're starting to see it, it's like, okay, this is really starting to come to fruition. And all those plans that we had around, why is it important for us to have something that's not InfiniBand, something that is more AWS-like, that fits within our architectures and the way we think about elasticity, and just that plethora of instances that you had up there, Boof, shows why EFA is such a core technology for us, and how we're going to continue to expand that list. I'll be excited to see what that list is like in a year from now.
Yeah, I'm going to go back and actually get all of the release dates of all of those instances and plot them on a timeline, just to see if it is actually an exponentially increasing number of instances supporting EFA, because I suspect it is. We are kind of going berserk at this sort of latter end of the year. My camera is starting to get really shaky.
But speaking of hardware, let's get to the most exciting thing. What everybody wants us to talk about.
Oh, okay.
Graviton 3.
Shouldn't you be wearing like a big belt?
I should be holding up a big belt with a big G3 in it. I should get that for the Anna Lab.
Sumo style. Okay, so obviously we did this thing, and we released this. We announced this new CPU, Graviton 3. We used the words SVE. So this is an ARM-based processor. It's got ARM cores, and it's got SVE in it. I think we are now the only people offering an SVE-capable ARM processor to anybody with a credit card and a problem to solve. I think it's just this is pretty wild.
I've never been shy about being the genomics guy and the high throughput computing guy. Could somebody explain to me what the importance of SVE is? Sorry, I just I just use the code. I don't develop the code.
Hang on, by the way, is my video getting really shaky?
Yeah, don't worry about it for right now, though. Because
I'm gonna have to
put up my hand
later. It's fine.
But
it blows up in my audio is all that's left. We'll live with it.
Can you put up that slide with the not that one, go back. One of those. Anyone that
one?
The one with the picture.
Yeah, top one.
There we go.
Yeah. Okay.
I think one of the cool things about the Graviton 3 is that 7 chiplet design there, and you can see it in the picture. And actually, while I was at reInvent, I was able to hold one of them. Ali was gracious enough to allow me to hold one in my hand. Of course, he wouldn't let me take a picture of it and post it, unfortunately. But you can see it looks just like that. It's pretty impressive. It is about the size of my hand, and just seeing the design implementation there, over 50 billion transistors crammed into that. And if we want to go to the next slide, we can go into
DDR5, by the way. Wow.
What those different aspects of it are doing. You can see specifically the differences between the Graviton 2 and the Graviton 3 on the right. Basically you take everything and almost double it between the Graviton 2 and the Graviton 3. How can you not like that?
Yeah.
Especially since we've been publishing so many application price performance, looking at x86 architectures versus Graviton, and seeing Graviton 2 hold its own against some pretty recent x86. Now, double Graviton 3. We're going to have to redo a lot of our work, honestly, but it'll be an exciting result at the end of it.
And you're absolutely right. It's going to be some of the really vector heavy codes that this is going to absolutely just munch on. We're only early days in actually testing and doing any of the benchmarking on these chips, but as soon as we've got some, you can be sure we'll start sharing it widely. There are a few other things that were just weird about this platform, about this server.
Yeah, and let's be, for those that not, this is kind of inside baseball, but let's clarify between the instance, the C7G that we kind of started up the graphic up, and the chip itself, the Graviton 3. And so that's where the innovation didn't stop at the chip level. And this is what's so exciting about the C7G, is we got really close and people started talking about what would it take to get this to where we could have not 2, but
not 4, but
but 3.
So we have 3 socket motherboards.
Ours goes to 11.
Yeah, that's right. So we have 3 socket motherboards. This is weird, but it increases the actual server density enormously, and it means that because real estate's a premium. We can't pour concrete fast enough. Plus, we want to cram as much heat into one spot as we can. Actually, maybe that's not the objective, but it's certainly what we're doing. It's definitely weird. But how does it? So 3 Graviton chips using 1 network board.
Mm-hmm.
Yep.
Yes.
Fine.
Yeah. Again, so calling back to our investments in our own infrastructure and our own way of doing things, and offloading a lot of the functions that you would expect allowed us to scale. EC2 itself, that Nitro architecture, is what's leading to the innovation for C7G. So again, all these stories are playing together, that we're marching forward in a great way. What's good for EC2 generally is what's good for HPC, and vice versa. So really super exciting. Anyway, but this
if you could go back one, and there's a real world example, right? And we talked a little bit about how impressed some of the Graviton 2 benchmarks were versus x86, and now we have Graviton 3 versus Graviton 2, and you can see it's even more impressive. So, and these are real world HPC applications. This isn't, okay, your web server will run a little bit cooler and you'll save some money on it. This is a highly demanding computational fluid dynamics workflow.
Mm-hmm. Yep. And it's and the fact the fact that you can get your hands on these things for a couple of bucks an hour, you'll be able to get your hands on these things and actually run them. That's game changing, because at the moment the only folks in the world who've got SVE enabled ARM processors, you have to be a top 5 supercomputer site. That's pretty much the only place that those things are playing right now. So, like I said before, anybody with a credit card and a problem to solve is going to be able to access one of these things soon. So if you're watching this, sign up to the preview. Let us know what kind of experience it is. We're definitely keen to hear a lot more about what's going on. Now the last thing, I don't want to share a video file. The last thing before we totally run out of time. Angel, we have to talk about AWS HPC connector for nice engine frame. Mm-hmm. Little mouthful. Maybe we can get snappier with our naming in the future. But,
you know how we love naming.
We're very famous for easy to say names.
We're not being frugal with characters in our names. Anyway, so nice engine frame is leveraging it's leveraging a whole lot of the work that we did in Parallel Cluster that led up to Parallel Cluster 3.
Yeah, the development group here at HPC Services has been marching towards like, yeah, parallel cluster is fantastic for our customers to stand up, scalable clusters. It takes care of a lot for you. But when they were looking at the version 3 as a major initiative to uh, remove some of the cruft that has been there over the years, but also improve the picture for foundation for the future. One of the major features of Parallel Cluster 3 was creation of an API so that you can control infrastructures from more than just your laptop or the command line that you have. That was the initial place where you were command and control of Parallel Cluster. So once we released that, the dev group that was doing Engine Frame, which is a software that we have that provides a visual web portal for HPC, it's risen to tries to make HPC available to a wider audience, folks who know more, don't know the command line, don't know the individual particulars of each flag of their scheduler or the application, but they still need to run these workloads. They still need to run fairly sophisticated applications. These web portals work for them. So with Nice Engine Frame, we put that together with Parallel Cluster to create this HPC connector. So Engine Frame's been used by on-premise HPC providers for a very long time. Folks have also installed it on AWS on top of Parallel Cluster to create that easier interface for Parallel clusters. But it didn't do anything special between those two products. You still had to know all of AWS. You still had to know all of Engine Frame. So in order for us to actually meet the needs of our customers that need to leverage both on-premise and in the cloud in a hybrid fashion, we started marching towards this vision of a hybrid HPC set of softwares. And this is the first release. It's an initial release of the integration of Engine Frame and Parallel Cluster. What it's essentially doing is that you're now registering configurations and then also managing those clusters that are bootstrapped from that configuration directly within Engine Frame. And it also does one or two extra functionality around there to move data from on-premise automatically over to your storage system prior to running the job and then managing the results coming back in. Caveat emptor, right now the user the user management in Parallel Cluster between Nice Engine Frame and Parallel Cluster is a little limited, as well as the data movement. But these are features that are really very high on our roadmap, get better user management, better security, authentication, authorization, and more guidance for our hybrid HPC customers on how to leverage these two tools in the best way possible. So I think it's pretty exciting. We're seeing the development efforts on Parallel Cluster 3 pay off, not just for our customers, but for our own products ourselves. We're dog fooding this, and we're going to keep chowing down on this problem over the next year. Very exciting.
And I think what's important here is to see, while we've got hundreds and hundreds of customers that are happy with the cloud native workflows of Parallel Cluster, there's a real significant user base that has made an investment in on-prem hardware that say, I really need something that helps me do both. I'm not willing to say, okay, I'm going to shut everything off right now and move entirely into AWS, but I still want to leverage that. I want to take advantage of the elasticity of AWS. How can I use something that's also aware and managing things on my on-prem hardware to also then elastically expand into the cloud? And so that's what we hope with. This is just an initial step with kind of integrating Nice Engine Frame with AWS Parallel Cluster and allowing customers to launch those clusters from Engine Frame. But one of our focus going forward is going to be to continue to expand to support those customers that want further functionality to support their hybrid on-prem cloud environments.
Well, this is kind of an inevitable. This was a really clever move, because I think one of the first conversations you and I had, Ian, when you first joined AWS was about Engine Frame and the Nice company after we'd acquired them, right? And we were, one of the things that had us most interested in Engine Frame is the fact that it's a great productivity tool for human beings who need to use HPC clusters without needing to get into all of the gritty detail of how to create a batch submission script for Slurm or PBS Pro or something, right? And it's almost like it was a really easy to use interface for, for chemists and scientists and CFD engineers and stuff to be able to do their HPC in a faster and more productive way. That it seemed like an obvious thing to merge that with cloud. The fact that it took us 5 years to get there, we won't mention. I'm going to edit that out. All right.
That's the editing.
All right, we've covered enough. I'm going to edit some good stuff out of that. Is there anything we missed?
No, I think this is great.
Just one last thing, and I wanted to put a plug in, and you can edit this out if you want. But I think one of the key aspects, I think Angel would agree, is getting back to human-to-human engagement. That's not mediated by this video platform, and so that's why, unlike SC, which was a little bit sad. Honestly, the show floor was pretty empty. It was sparse. It was good to start meeting customers again face to face and be able to see people. There really was a vibrancy and a life around reInvent that made it feel more like, okay, we're starting to get back. And everything felt very, very safe, very very well done, and yet we were able to get back to customer to engineer engagement and to really talk about what are the real hard problems that our customers are trying to solve, and how can we better develop solutions and services to support them. And that's one of the best things for me out of reInvent is all this technology stuff. We just get kind of used to that wheel turning every year at reInvent. But after having a pause from last year, because of the virtual nature of it, and getting back to actually being able to meet with customers face to face and be able to hear from them what are the things that they love that are actual game changers for the way they do business, but then are actually what are the areas that they'd love to see us make improvements, and those continue to push us to innovate. And that's one of the things that I love most about reInvent.
Yeah. I missed being there. I really did next year. But as my video during this call is indicating, maybe I'm actually not real. Maybe I am. Yeah, I'm either Max Headroom or I'm a glitch in the Matrix. All right,
guys. I'm going to go see how the world's burning down.
Yeah. Thank you, gentlemen, for coming today. We'll wrap up there. If anybody out there, hang on, let me do my thing. If anybody out there has got any other topics that they want to see us deep dive in future tech shorts, please DM us on Twitter. Our DMs are open. Otherwise, we'll look forward to the next one. Thanks, Ian. Thanks, Angel.
Cheers.
Okay, you're good.
All right. Later, man.
See ya.